All right, folks, here we have an exercise of graphing a rational function. We want to graph y equals 4 over x minus 2. To graph irrational functions, you have to follow these steps. First thing you do is finding the vertical asymptotes. We're going to call them VA from now on, vertical asymptotes. To find the vertical asymptotes, you set the denominator equal to 0. So x minus 2 equals 0, and you solve. The result will give you your vertical asymptote. So you send 2 over to that side. That means x has to be equal to positive 2. So the vertical asymptote is going to be at x equals 2. Next, you have to check the multiplicity of the denominator that you used. This is to the power of just 1. Right? That means it's an odd multiplicity. When it's an odd multiplicity, imagine you have your vertical asymptote drawn out. When it's odd, either side of that asymptote will behave differently. If on the left it went upwards towards that asymptote, on the right it would go to the bottom. Right? So either both sides are going to go in different directions, or the other possibility is that on the left it goes down, and on the right it goes up. So these are the two options we have for that vertical asymptote. This is going to be at x equals 2. Because it's an odd power. Next thing you do is you find the y-intercepts. To find the y-intercepts, you simply set x equal to 0 in your equation. So y is going to be equal to 4 over 0 minus 2. And you simplify. Y is going to be 4 over negative 2. That means y is going to be negative 2. This is our y-intercept. That means on the y-axis, you have to put that point. It means that the graph passes through negative 2. Then, step 3, we find the x-intercept, if there are any. Sometimes you might not have an x-intercept, but you will almost always have a y-intercept. Oh, that's not true, it depends. But you might not have an x-intercept. Let's check. To find the x-intercept, you set y equals to 0 in your equation here. And you solve for x. So 0 equals 4 over x minus 2. You multiply both sides by x minus 2. That means 0 times x minus 2 is equal to, this is as if you have 0 over 1. So 1 times 4 equals x minus 2 times 0. 0 times anything gives you 0. So 0 equals 4. This is not possible. 0 is not 4. This means that there is no x-intercept. This is undefined. No x-intercept. Great. Now the last step is to find the horizontal asymptotes. Which we're going to refer to as HA from now on. So you have to look at the greatest power of the numerator and compare to the greatest power of the denominator. Over here, you don't have any x's at all in the numerator. So that means the greatest power of the numerator is 0. In the bottom, you have 1x, and this is to the power of 1. So the greatest power of the denominator is equal to 1. Now we know we can have 3 cases. Case 1 is when the power of the numerator is greater than the greatest power of the denominator. Case 2 is if the power of the numerator is equal to the power of the denominator. And case 3 is if the power of the numerator is smaller than the power of the denominator. When the power of the numerator is greater than the power of the denominator, you have no horizontal asymptotes. When the power of the numerator is equal to the power of the denominator, you have a horizontal asymptote, and is given by the fraction of the coefficients. So when the numerator's power is equal to that of the denominator, it's given by it's given by the fraction of the coefficients of the greatest power of each. When the power of the numerator is equal to the power of the denominator, the horizontal asymptote is given by the fraction of the coefficients of the greatest powers. In other words, it's given by the fraction of the leading coefficients. This is not the case over here. Over here we have the power of the numerator being smaller than the power of the denominator. When that happens, then the HA is simply y equals 0. So this is our horizontal asymptote. All right? So we're going to go over to the graph, and we're going to put all these points in graph. All right, here's our graph paper. We're going to start off by putting the the vertical asymptote. The vertical asymptote was x equals 2. So let's go ahead and put that over here. X equals 2. Since it's a vertical asymptote, it's an asymptote, I'm going to draw it as a dotted line. I don't know if you can see that. Maybe I can do it with a marker. Nope, maybe I can't do it with a marker. Let's draw it a bit thicker. This is our vertical asymptote. There you go. Now, it goes without saying, this is the x-axis, and that's the y-axis. Now we're gonna place our y-intercept. The y-intercept is at y equals -2. So let's go on the y-axis and go to -2 and place that point over here. Next, we're gonna place the x-intercept. Oh no, we don't have an x-intercept, so we're gonna move on to the horizontal asymptote. It says the horizontal asymptote happens at y equals 0. Well, that makes sense. We don't have an x-intercept because we have an asymptote over the x-axis, y equals 0. So at y equals 0, we're going to draw a dotted line. Y equals 0. I don't know if you're going to see this. I'm going to draw it a little bit underneath. There you go. All right. So we know that the graph has to pass through this point and approach these two asymptotes. Well, if it has to pass through this point and approach this vertical asymptote over here, then it's probably going to look like this. Right? It's going to go up over on this side and down over on that side. Since this is we know that the vertical asymptote, we said that it has a multiplicity 1. So on either side of that asymptote, it's going to behave differently. Well, on this side is going down, so on that side is going to go up. And it's going to approach that asymptote over there. Right? We don't have any x-intercepts, so the graph is not going to cross that horizontal asymptote, and this is the solution. This is the graph of 4 over x minus 2. There you go.